Okay, practice problems. So what I think would be a good idea now that we've gone through those other ones up top, these three practice problems are actually pretty much the same as the ones we just did up there. See if you can do these ones and then come back to this video and then watch it if you can't, or just to check out to see if you got the same answers as I did. Okay. So number one says 100 or a 600 kilogram mass is connected over a pulley to a 400 kilogram mass. What's the resulting acceleration when the masses are released? What's the tension in the rope? So we are going to call on the right side of this thing, down is going to be positive, up is going to be negative because that's going to be the way it's going to accelerate. And on this side, up's going to be positive, down's going to be negative. So let's make a free body diagram for the system. So make a dot, and this is for the, like, both of them together, 400 plus the 600 together. And we're going to say going downward is going to be the force of gravity of the 600 one. So let's figure out the both of those actually. But I'll finish this one though. So we're gonna have that, and then going up, we're gonna have force of gravity of the 400 kilogram one. So let's figure out what the force of gravity in both those ones were though. So Fg here for this one is going to be mass times gravity. So Fg would be 600 kilograms times 9.81 meters per second squared. Fg, I'll put 600 there again. It's going to be 5,886 newtons. Okay, on this side, Fg 400 is going to be 3,924 newtons. That was just mass times gravity. I just didn't show that time. Okay, so we got that one. We got that one. All right. So now we can say F net for the system is just going to be Fg for the 600 plus Fg for the 400 one. I'll put the little vector symbols up there. All right, so that's going to be, remember Fg is going down, but now down's positive. We're calling down positive on this side. So this is going to be, what's that going to be? 5,886 newtons, and then plus negative 3,924 newtons. So the net result here is going to be 1,962 newtons. So that's F net. Okay, so if I want to figure out what the acceleration is of these, I just need to go, well, acceleration is going to be equal to F net over mass, and knowing that mass is the mass of both. So acceleration is going to be 1,962 newtons divided by 400 plus 600 kilograms. And I haven't done that yet, but that's a common way to write. If you're adding things together, you can just add them without units in the brackets and then put the units at the end of the brackets. That's totally a legit way to do it. So that's going to be 1.962 meters per second squared. Okay, now I wish I would have left more room. I'm kind of taking up way more than I need to. Now for the tension part of it, we're going to look at just one of the masses. I'm going to choose the 600 kilogram one because we can just keep down as being positive, so we don't get messed up with that. So let's draw a free body diagram for that one. So that's going to be there. Down is going to be Fg 600. Up is going to be our force of tension. So F net is going to be Ft plus Fg for the 600 kilogram one. Okay, we know Fg. We figured that out right off the bat. We don't know F net yet, but we can figure that out pretty easily by going F net is equal to mass times acceleration, and our mass is 600 kilograms. 600 kg times our acceleration that we just figured out, 1.962 meters per second squared. So F net's going to be 1,177.2 newtons. Okay, so now that we know that, I'm going to go back over to the left side here. I'm going to rearrange for Ft. Ft is going to be equal to F net plus Fg. So Ft is equal to 1,177.2. Whoop, I rearranged that wrong. It should be F net minus Fg. Okay, so 1,172 minus, now Fg was, what was Fg again? 5,886. So Ft is 4,709 newtons. Okay, so hopefully that made sense. Moving on down. Okay. So if we made a free body diagram for this thing, I'm going to say there is a force of friction going this way. Force of friction A, I'm going to call it. There's going to be a normal force going up, so Fn. There's going to be a force of gravity going down, that's the same. And there's going to be a tension force going forward. But that's going to be canceled out by the tension force going this way. Okay, and block B, I'm going to have a Fn going up. I'm going to have an Fg going down. And I've got a force going this way. Okay. This one's actually going to be easier than the one that was above. And the reason for it is because they have given us, well, they've given us the applied force. So F applied is going to be 150 newtons going that way. And they've also given us the force of friction A and the force of friction B. So we can just right off the bat make our free body diagram for the system. So I can say the free body diagram for the system here is going to be the force of friction A, and then force of friction B, just the two of them together. And then force applied. Okay, so let's say our net force is going to be equal to just all of those things, the blue, red, and the black together there. So that's going to be Fa plus force of friction B plus force of friction A. So force of friction A was positive 150 newtons. And then plus, now the force of friction were in the negative direction, so force of friction B, it says mass A has entered mass B 70. So 70 newtons, oh sorry, negative 70. And then plus negative 50 newtons. The net force here is going to be 30 newtons in the positive direction. Okay, so it says find the acceleration of the system though. So acceleration is just F net over mass, and the total mass, right? So acceleration is going to just be equal to 30 newtons divided by 20 plus 30 kilograms, which is equal to 0.60 meters per second squared. All right, last one. So what is the acceleration and tension in the rope for the pulley system shown if the coefficient of friction is 0.23? Okay, so let's do this one first. Let's figure out what our force of gravity is. And let's call on this side, it's going to be accelerating downward, right? So down's going to be positive, up's going to be negative. So I'm going to say, if we do our free body diagram for that one first, Fg is going to be equal to 1 kilogram times 9.81 meters per second squared. So Fg is going to be equal to 9.81 newtons. Okay, got that one figured out. Now we got to figure out what's the force pulling this thing backwards. So really what we're after is what's the force of friction on this one. So we've got force of friction pulling that way. We got one pulling that way. We've got Fn going up. Here, let's try that again. Fn going up. We've got Fg pulling down. So Fg is going to be the same as Fn, right? So let's figure out what Fg on this one is. So Fg is just 3 kilograms times 9.81 meters per second squared. Is going to be 29.43 newtons. All right, so now we kind of figured out, yeah, so Fg. We need the force of friction though, but this is also, so I'm going to say therefore, Fn is equal to 29.43 newtons. So now let's figure out what the force of friction is. Force of friction is going to be equal to the coefficient of static, or coefficient of friction, times Fn. So that's going to be, what was our coefficient of friction? 0.23 times 29.43 newtons. So our force of friction here is going to be 6.769 newtons. All right, we're good. We can make our free body diagram for the system. So if we do that, we've got the beginning of this, or the dot here. We are going to, I'm going to make this one horizontal probably. You could have made it up and down too, but I'm going to make it horizontal. So we've got the force of gravity of the 1 kilogram one pulling this way. So Fg, I'm going to call it Fg1. I guess I should have named that earlier. So Fg, which is 9.81 newtons. And then pulling backwards, you've got the force of friction. So 6.769 newtons. So we just need the net force between those two. So the net force is just going to be negative 6.769 newtons plus 9.81 newtons. And we get 3.041 newtons. So in the positive direction. And then last step, we got to just go A is equal to 3.041 newtons divided by the total mass. So 4 kilograms. So that's 0.769 meters per second squared. Oh, and it wants the tension. Of course it wants the tension. All right, so now we got to look at just one of the masses. I'm going to look at the 1 kilogram mass because one's easy to deal with. So let's make a new free body diagram where we're just looking at the 1. So we've got Fg of that one pulling down, and we got the tension pulling up. F net is going to be equal to Fg plus Ft. We know Fg. Here, I'm going to rearrange for Ft right now too. So Ft is going to be equal to F net minus Fg. So we know Fg. We knew that a long time ago. F net, we got to figure out though. So we'll go F net is going to be equal to mass times acceleration. Our mass here is just going to be 1 kilogram. And our acceleration is going to be the acceleration that we just found, so 0.76 meters per second squared. So F net's going to be 0.76 newtons. All right, so let's just fill those in. So Ft is going to be 0.76 newtons minus Fg was 9.81 newtons. So Ft is negative 9.04 newtons. And what should my sig digs be? I should probably only have 2 sig digs, I bet. Yeah, because coefficient of friction here, and our numbers only have 2, so my answer should have only had 2 sig digs. So this should have just been 9.0 newtons, and it's in the negative direction, so it's pulling up, which makes sense. Okay, so go ahead and do the hand-in assignments now. Yeah. Oh, I've got some other ones too, some bonus questions. Go ahead and give those a try too. But they're not going to be mandatory. But you guys will have a test coming up here soon, so they'd probably be a good thing to give a go. Okay, so that's it for that one. And that's the last lesson in this unit, actually. So congratulations.